Stop. Recording in progress.
Hi everyone, welcome to my channel, Maths Made Easy with Terry in 10 minutes. We're going to go straight to definite integration and we're going to talk about how do we solve questions relating to definite integration. Before I proceed, I would like to ask that if you've not subscribed or you've not liked or shared this video, I advise you to subscribe so that when I post a new video, you'll be the first person to know. And how do you know? Is by clicking the notification bell as well. All right, so let's get started. So as discussed in the previous video, I told you that an integral with limit is called definite integral, right? So let me write it here. So an integral, okay, with limits is called a definite integral. Okay. Okay, it's called definite integral. So that means you're having an integral like a, b, so we have x raised to the power n. So this is what we call a definite integration, okay? So, and I told you that when you have something like this, like in this example, okay, the a here is called the upper limit, okay? Then the b here is called the what? The lower limit. And when you're solving definite integration, it's exactly the same thing, but the only difference here is that the c's are not used as well, it's omitted, as well as you substitute the upper limit and you substitute the lower limit and you find the difference of the two results, okay? So like I said, with definite integral, the constant of the integration is maybe omitted, not because it's not there, but usually because it occurs in both brackets and it disappears in the subsequent workings, okay? So usually we solve the definite integration without using the C, because usually when you solve it, it cancels out. All right, so let me just write it down. So what I said is that with definite integration, okay, with definite integration, let me say the definite integral, I think integral, okay? The constant of integration may be omitted. Okay, so not because it is not there, but because it occurs in both brackets. Okay, and disappears in subsequent workings. Okay, so it's not that the C is not there, it's just that the C disappears because when we finish up the workings, it's gonna subtract each other and gonna just cancel out. All right. So we're gonna talk about the 5 rules of doing this. So what are the 5 rules of using the definite integration? So we're gonna talk about the 5 rules now. All right. So the first thing is that you have to integrate the function or the question, normally using the appropriate rules from the 15 rules of integration we've talked about. and you have to ignore the limits at this stage, okay? So the first thing you do, you integrate the function or question normally using the appropriate rules. Okay, so you do it using the appropriate rules from the 15 rules. Of integration. Okay, now, and you have to ignore the limits at this stage. So you have to ignore the limits at this stage. Okay, then number two, what you then do, you then substitute the upper limit into step one. Number three, next thing you do, you substitute the lower limit into step one. Then number four, you then subtract the results from step one. Or you basically result from step result from step 3 from 2, okay? So result from step 3 from step 2. So what I'm saying is that you're gonna be step 2 minus step 3, okay? And number 5, you then what? Simplify. Okay, so these are the 5 rules. So you integrate the function normally using any of the 15 rules, okay? Then you now substitute the upper limit into step 1. You now substitute the lower limit. Then you subtract step 3 from step 2, okay? That is step 2 minus step 3. Then after that, you then what? You then simplify, okay? All right, let's pick an example to explain this. Example. Okay, so let's assume that we have an example here. Let's say we have 8, 4, we have x plus, let's say we have, I'll put it this way, 8, 4, okay? And we have x plus 3x squared. And we are meant to integrate this in respect to x. All right, so I'm going to use a method and I'm going to add c. So I want to just prove what I said here, all right? So remember I said with definite integral, the constant, okay? So I'm talking about the constant here. I said the constant of the integration is omitted, right? So I'm going to solve this now, but I'm not going to omit the constant, all right? Just to prove what I'm trying to say, that you don't need to put the constant, the c, in the question. Okay, so I'm going to solve this, and I'm going to put the constant there. So let's go. Step one, we're told that when you're doing step one, the first thing to do is that you have to integrate the function or the question normally using the appropriate rules from the 15 rules. So this is similar to the sum rules, okay? So step one, we're gonna use the sum rule here. So step one is gonna become we're integrating, all right? And at this stage, we're told to ignore the limits, right? So we're gonna ignore the limits. We're gonna ignore the limits at this stage. So we're gonna integrate this normally. So it's gonna be square x plus, we're integrating 3x squared, all right? So I've done all this before in the previous video. So I'm gonna just jump straight and solve it normally. So this is gonna become, this raised by 1, so it's gonna be x. 1 plus 1 will give us 2 divided by 2 plus, you bring out a constant, so it's gonna be 3. It's gonna be x. 2 plus 1 will give us 3 divided by what? 3 plus c, all right? So I'm doing the c now just to prove to you that there is no need of writing the c will disappear. So 8 and 4. Are you seeing it? Now, step 2 now said that we then have to substitute the upper limit into step 1. So we're going to substitute the upper limit into step 1. So let's go. So step 2, let me clean this here. So step 2, we're going to substitute the upper limit. So step 2. So it's going to be, the upper limit here is 8. So it's going to be anywhere you see x, you're going to put 8. So it's going to become 8 squared over 2 plus 3 8 cubed over 3 plus c. And that was going to give us, when you now solve this, it will be equal to 444 plus c. Are you seeing it? Then we now go to step 3. So step 3, what does step 3 say? Step 3 says we then have to substitute the lower limit into step 1. So we're going to substitute the lower limit now at this stage. So instead of this time, the lower limit is 4. So we're going to substitute 4 anywhere we see x. So it's going to become, so we're going to have 4 squared all over 2 plus 3 4 cubed all over 3 plus c, all right? So the answer we're going to get here when you solve this correctly is going to give you, I think, 72. So it's going to give you 72 plus c. Okay, now let's go to step 4. Step 4, all right, so step 4 said that it's going to become step 2 minus step 3, all right? So let's go. Step 2 minus step 3. So it's going to become 544 plus c, all right? Minus 72 plus c, all right? So you open the brackets. So it's going to give us 544 plus c minus 72 minus c, because the minus is going to open the bracket. So it's going to be minus 72, and minus times plus will give you minus. You collect like terms, so it's going to give us 544 minus 72 plus c minus c. So you can see the plus c and the minus c cancels out each other. Is that making sense? So this is going to cancel out this. So you're going to be left with 544 minus 72, and that is simplified. That is step 5. And this is going to give us what? 472. So you can see why we don't put the c. So you can see that if you even add the c cancels out. So that means the constant term disappears, all right? So it's not that it has not always been there. It's just that indefinite integration is there, but it cancels out. So when we do solve, we don't just add the c, we just keep on solving. All right, so With that said, now the subsequent examples I'm going to solve now, I'm not going to use C. I'm going to just solve it because I know the C is going to cancel out. Is that making sense? All right. And that is that for that. So let's pick another example then. All right, let's pick another example. So this example 2. So let's make it interesting. So let's say we are having integral of 2, 1, and we have 3 exponential 6x in respect to dx. So you can pause the video here. All right, you can pause it here. You can try as much as possible to solve it, and you can come back and play, and you can see if we get the same answer. So like I said, in step 1, you ignore the integral sign and you just solve. So like I always say, ignore the upper and lower limit, I beg your pardon. So you take the 3 out there, so it's going to become 3 integral of what? Exponential 6x. Are you seeing it? Then the next thing is that we integrate this. So I've taught you how to integrate exponentials. So you differentiate the power and you divide by the original question. So it's going to be exponential 6x. When you differentiate the power, it's going to give you 6. Are you seeing it? Then we now bring back the limits. That will become 2 and 1. So if you want to, you can also break this down. 3 can divide 6. Or before you do that, to make it easy. All right, so I can make this to be equal to 3e 6x divided by 6. And this is going to give me 2, because this is going to divide 3 here, 1. 3 here going to be 2. So it's going to become exponential 6x divided by what? 2 into the x is what? 2 and 1. All right, so that is step 1. So now we can go straight to step 2 now. So step 2, we then have to substitute the upper limit. All right, so we're going to substitute 2 into this. So it's going to become, that'll be good, exponential 6 into bracket 2 divided by 2. Is that making sense? And that will be the answer for that. Then for step 3, all right, step 3, you substitute the lower limit. So it's going to be exponential. Now, what is the lower limit in this example is 1. So it's going to be 6 into bracket 1 divided by what? 2. All right. Then the last part now, step 4, we then have to subtract step 2 and 3. So it's going to become, the first one is 6 exponential 2. So it's going to be, this is going to be exponential 6, 2 divided by 2, all right, minus exponential 6, 1. Six, 1 divided by 2. Then step 5, so we can now add and step 5. You just press your calculator. And this should give you about 8,100, or I think 81,175.68. And that should be the answer. So you can check if you got exactly the same thing like I did as well. So that is pretty much the same thing for definite integration. What you just have to do is that you just have to integrate it as normal. And when you integrate it as normal, then you substitute the upper limit, substitute the lower limit, and you subtract it from each other, okay?
Recording in progress.
All right, so let's make this a bit more interesting. Let's just take the level a bit higher now and see that this also applies when you're looking at a more complicated integral form. So let's look at number 3, for instance. Let's assume you're told to integrate between 2 and 1, 3x. So we have 3x minus 4, okay, power of 4 dx, okay? So this is going to talk about, I think, rule 12 or 13, where we talked about integration by substitution. So if you've not reviewed the further integration series on integration by substitution, I don't think you can solve this question here because I'm going to use the substitution method to solve this. All right, so I'm going to be using substitution method to make this interesting. Okay, so I'm going to use substitution method. So for this, I'm going to let u, all right, I'm going to let u to be equal to 3x minus 4, all right? Then, so remember in substitution method, I told you that the aim of substitution method is to replace all the x and the x with u. Then we're going to integrate it normally. Then we're going to apply the new limits for u's as well. And then we'll now apply the definite integration. So it is very imperative that you go back and you look at my videos on how to do substitution method and how to solve questions on it. So now we have let u to be equal to 3x minus 4. So that means the u over the x is going to be equal to 3. So therefore, we have now the x is going to be equal to what? The u over what? 3. So now, based on this now, we can now say, because we know the u is equal to 3x over 4, we can rewrite this question again as 2, 1, u raised to the power of 4. Now, but we know that the x now, that the x is the u over the 3. So it's going to be times the u over what? 3. Now, also, I told you as well that we need to also change the limits. So the limits has to change as well because you can't use the same limit. So we have to look for the new limits. So I told you need to look for the new limits. So the upper limits now, what is going to be? So we're going to have the u will be equal to 3x minus 4. So it's going to become 3. X is 2. So it's going to be 2 minus 4. Does that make sense? So that means this is 3 times 2. Will give you 6. And 6 minus 4. And that will give you what? 2. All right? So then the next thing as well, we can now get the lower limits, the new lower limits. So the new lower limits as well, the u we're going to have is going to be 3 into bracket 1 minus 4. And this is going to give us 3 minus 4. And that will give you minus 1. So that means we're going to rewrite this question again with the new limits. So the limits we have for x is going to be, so we have 2. So what we put in 2 here is going to become 2, then minus 1, u raised to the power what? 4, and multiply by du over what? 3. Okay? U raised to the power 4 minus du over what? 3. Now, the next one is that we then have to this is what we then integrate. So we're going to integrate this now. So we're going to have, we have the integral sign of 2 minus 1 u raised to the power 4 divided by 3 du. Okay, so let's get it on from there. So I bring out the constant, so it's going to be 1 over 3 integral of what? U raised to the power 4. Okay, the u between 2 and minus 1, and that's going to give us 1 over 3 into brackets. It's going to be u raised to the power what? 5 divided by 5 into bracket 2 and minus what? 1. Okay, then what do? You can do, we know the u, we know the value of the upper limit of 2 and lower limit of 1. So you can also do it in this way. You can also open the bracket to make it easier for you. So you can say, this is the same thing as saying u raised to the power 5 divided by 15, everything 2 and what? Minus 1. So we substitute the upper limit, minus 1 is substitute the lower limit. So it's going to give us 2 raised to the power 5 divided by 15 minus 1 raised to the power 5 divided by what? 15. So remember, you substitute the upper limit, minus 1 you substitute the lower limit.
Recording in progress.
So this is going to give you 11 divided by what? 5 as the final answer. All right. So that is it for that. So for those of you that have not reviewed substitution method from further integration, I would advise you have to look at this before solving this question, or else it's going to be a real challenge for you. So I'm going to give you some harder ones to try. So you want to try this? Number 1, I want you to integrate between 5 and minus 2, x4 in respect to the x. Number 2, I want you to integrate between pi over 2, this is pi over 2 and 0 for 2x cos, or make this one for pi and 0 cos 3x, okay, in respect to x, okay? Number 3, I want you to solve between 5 and 2, 1 over x plus 8. Number 4, I want you to solve between 2 and 0, 2x minus 3 raised to the power 4. Number 5, I want you to solve, same thing, pi over 2 and 0. I want you to solve 2x cos x in respect to the x. And number 6, I want you to solve integral between 3 and 1 x squared. Okay, so what I want to do, I want you to try these questions, all right? And I want you to now, you can put your answer in the comment section. So let's see what other subscribers think about this, okay? And if you have any question and you can't answer it, please send me a message and I'll get back to you. You can send me an email and I'll get back to you. So the next one, I'm gonna just quickly go over the indefinite, just a quick reminder. And after that, we'll now go straight to area under the curve. So it is important that you subscribe and click notification bell so that when I post new videos, you'll be the first person to know. All right, so I'm going to see you soon in the next video where we'll talk about the indefinite integration. So see you soon.